In this section, we will cover the basic of how to present a proper signal. In order to present a proper signal on the scope, you should know what to expect. For example, in this case, we are entering a 100 milli V peak to peak, 1 kHz sine wave to an amplifier. We expect that the output should be much larger than the input. First, we will choose our coupling. As we said, we are entering a sine wave, and we want to measure the gain of the amplifier. So we'll choose AC coupling for both signals. This way our signal will be centered around the channel reference point. Switching channel 1 to AC, channel 2 to AC. Note how the trigger is moved, and I should center the trigger back to the middle of the waveform. In this case, if we wouldn't have used DC coupling, we would still see a sine wave on the scope. So let's switch, for example, channel 1 to DC coupling. As you can see, we still see sine wave on the scope. However, watch that the reference point is down here and the center of the wave is right up here. This is the DC offset. In DC coupling, we're seeing the DC wave and the AC wave together. We can perform here measurements. However, performing a DC coupling measurement to an AC wave is incorrect. Moreover, if I will increase the vertical scale of channel 1, the signal will simply disappear. However, in channel 2, which is in AC mode, if I will increase, see how the signal increases around the center of the wave, keeping it leveled. So let's return channel 1 back to AC coupling and set the trigger. Now we need to choose the vertical scale. Scaling is extremely important. The scope measures what it sees. That means that if the signal is too small, the resolution of the measurements will be imprecise. If the scaling is too small, the signal will not fit the screen. So let's say in this example, if I will decrease the scale, I won't be able to see the sine wave. However, if I increase the scale, now I have reached the limit, but in some cases I can simply get a straight line, not understanding what I'm seeing.